Okay, so today let's continue our discussion about Java secure coding. So secure coding rules, okay, in Java. And last class we started, and what over here we use is CMU's SEI, okay. So the SEI is a CERT, Oracle coding standard for Java. Okay, so let's do a quick review. If you recall last class, we discussed the first rule under object orientation, okay. So that's majorly discussed about encapsulation in the information hiding, okay, so private. And so we are quite familiar with this one. But for the second one, let's be careful when we learn inheritance, okay, superclass and subclass. So when you create a subclass, make sure you preserve dependence in subclass, okay, when changing superclass. So make sure about this one. And the heap pollution, this is more related to what we already learned about generics. So that's why we in Java it introduced about the generics concept, okay, because in legacy there is no generics. So that's regarding heap pollution. And the number 4 is regarding mutable reference, okay, for copying functionality. Okay, so let's be careful about this. For the mutable reference, there are a number of discussions. And we also, if your instance variable is mutable type, reference type, and when you return, that can cause a problem, is it? Because this contradicts with rule 1, okay? So we needed to be careful. And the further discussion is also about mutable input and mutable internal, okay? When we do copy, we need to do defensive copy. So defense majorly is you need to do deep copy. And deep copy, it may involve multiple levels, if you recall, that we learned like array or collection, like array list, linked list, okay, like those. And then for their type, and this is also mutable. Then in this case, so this is some collection. That then in this case, you need to have multiple level. Make sure it's a deep copy, okay, because even for the type, reference type, you also need to make sure it's a deep copy. Okay, so that's just a quick recall about what we discussed last class. And then let's see, yeah, let's start number 7, rule number 7, okay. Rule number 7 is regarding sensitive class, okay. So a sensitive class is a class contains private, confidential, other sensitive data. Then what to recommend, do not let them be copied, okay. So over here it says if a class is not meant to be copied, if we fail to define the copy mechanism, then it is insufficient to prevent copying. Okay, and here it involves another concept called copy constructor. And if you recall previously what we learned, constructor, There are two types. It's without arguments. So we call it a default one. Constructor. The other one we learned is with arguments, and that we call it explicit value constructor. Okay. And there is another type called copy constructor. So copy constructor is the argument, basically parameter, okay. When we plug in, we call it argument, okay. So parameter type is the class itself. So if you have, suppose, a class, employee, and you define like a public employee, and so this is a constructor. So for this constructor, the parameter type is also the class type. So employee, suppose E. Then this constructor, we call it a copy constructor. Okay. So that's what it means, a copy constructor. Okay, then here to give us an example for non-compliant code. So this is quite a simple class, is it? But be careful here, one of the instance variable. So this is an instance variable. This instance variable is an array. Because it's an array, so it's reference type. Okay, reference type. Okay, and this is a constructor. It's just a create. Is it array? Okay, and here we have a method called replace, and you define it as final. So if a method is final, then it cannot be overridden by subclass. Okay, we already know this concept. So replace and get is also a final method. Is it? And the print file name is also a final method. So that's about this sensitive class, okay? And then what over here is as, so here is a malicious class. And this malicious is a subclass of that sensitive class. And it also implements clonable, okay? And for this clone method, what it does is it just call superclass. The clone method. And superclass doesn't provide a clone method, so it's basically the default one provided in object class. Is it because object is a root class? Okay. And then let's see the problem. Is it? So this object is a subclass object. And then over here we create, we use the clone method. Is it? Okay, what the clone method is just call objects clone method. Okay, and then this is the first object get method. So it just get the file name. Basically, it's the file.txt. Okay, then what you do is you call the second object's replace method. And what over here is you will think that it will only handle second object's file name. It won't impact MS1's. But when we do the print file name, we will see the first ones also got changed. So you it impact first object also, is it? So that's why we call it malicious. So it make use of the whole, is it? So security whole, is it in the clone method? Why? Because over here it's called super start clone, but the file name is an array, it's a reference type. If it is a reference type, so this is not a deep copy. A deep copy for file name. Is it because if you do want to have a deep copy for the file name, there are two ways to do it. You either need to do new char. Is it? You need to create a new array and then do letter by letter copy for the file name. Or you can do array has method. So array you can has the clone method, do the deep copy. Is it? But over here you didn't. This one, this malicious didn't. So its intention is to pollute the superclass's clone method. Okay, so it can directly do the processing on the file name. Okay, so this is a way you take advantage of the security hole. Okay, so we need to avoid this. Okay, then what's the way we can do it? So because this is called the sensitive class. Is it? So for sensitive class, if you want, you make the class as a final class. If it's a final class, then it doesn't allow subclass. Oh, it's so annoying. Notification. So it doesn't allow subclass. If it doesn't allow subclass, and over here we saw one of attacking, is it in security word is to use subclass for attacking. But of course, that means you didn't design your superclass well. Then it leaves the attacker some possibilities. Is it to create a subclass? Then the subclass can take advantage. Like in this case, create that clone method that to get the attacking. Okay, so OOP design, on one hand, we can see it has advantage. Is it for superclass and the subclass? But on the other hand, we can also see it also, if not designed well, there is also possibility for subclass attacking. Okay, so we need to find some way to curb it. And there is some other way, not just for the whole class be a final class. You can also define the method as a final method so that it won't allow subclass to take advantage of overriding the clone method. Okay, so be very careful here. Okay, so this one we kind of understand it. And then what next one is regarding, if you recall this semester, we also learned inner class, nested class, is it? And what over here, this rule 8 is regarding, is about do not disclose private members of an outer class from an inner class. Okay, so that is what this regarding. So let's take a look. So over here, for this example, this is regarding coordinates class. And it has a nested class, inner class. And be careful, its accessibility, visibility is public, is it? And it provide also a public method. This public method expose outer class. So it's a private instance variable. Okay, so that's what over here regarding the relationship, is it? Then you can get access to the inner class and expose the coordinates, is it? So this is non-compliant code. What recommend whenever we have nested class. So when you design nested class, we recommend make it private and its method also as private. Okay, so that we can hide inner class and its method and the constructors. Okay, so that's the rule. Okay, recommend when you consider security design, okay, in your software. Okay, so this is regarding nested class. And then regarding, because sometimes we want to compare class, and then in this case, we compare class, not a name. Okay, so let's take a look what this means. So over here, it shows non-compliant. So non-compliant, anyway, so this is the object. If you want to know the object's class, you can call the get class method. For the get class method, then over here, you call get name, and you then use the equals to compare the name. That's not recommended, okay? Purely using string for the comparison. So what to recommend is you call the get class. That's it. And here is the Java's class. That's it. And you compare with class instead of the name. Okay, so be careful here. And then just like over here, it shows again that if you have two objects and you want to compare class, then don't do the get name, is it? You use the get class for comparison, okay, instead of the name. Okay, so that's regarding the class. Okay, then what next to recommend is that do not use public static non-final fields. Okay, so over here, so this field is a static field. So static field, we means it's a class variable. Is it? So class variable that can be accessed by all objects that of that class. So it can be shared, basically. So that's a feature that, and it says then attacker can replace it that with something. Okay, so what to recommend is, so sometimes some important information, you don't want it to be modified. Then the final, static and the final. Then this means it's a constant. That if it's a constant, it cannot be modified. Okay, so be very careful. Okay. So that's regarding this rule. Okay, then let's see. What is the next rule? Rule 11. Okay, rule 11 is when we write a constructor, it recommend if you throw exception, that can also cause trouble, cause an inconsistent state. Okay, and right now, we haven't learned parallel processing, multi-threading. Okay, and later on, like for Java, you can also do multi-threading programming, etc. For multi-threading programming, then the object partially initialized can be a problem. Okay, so just keep this in mind. Let's take a look at example. Okay, so this is non-compliant code. So we define a class, we call it a bank operation. And this is its constructor. Within this constructor, we said, okay, we want to do some security check. So only you pass some security check, then you can do something. If not, you shouldn't. But over here, it says, okay, if not, then you just throw some exception. Okay, so here is what this constructor, throw some exception. And then we have the great method. Okay, and here is that security check method. And then over here, we have a class. This class is another class called storage. And its instance variable is that class that we just defined, okay, bank operation. And it has a method called store, okay. And for this method, what it required is, it must, so the object must be created. Otherwise it won't. Okay, and this object must also exist, because if it is not, then it won't continue. If it is, then it will do the assignment to store BO to the BOP. Okay, so that's what this storage class does. Okay, then let's see over here. So here is the main application, is it to create a bank operation, is it, and if there is the exception, it will call it. Okay, and it assign it to null. And because it is null, this cannot work, is it? So this program will be exited out here, okay. Okay, then let's see. So there is an attacker. So here is an attacker. Attacker, so create a subclass of that bank operation. Okay, so it create a subclass. And it has a get method. What the get method does is it create an object of itself. Is it? And this is, don't worry, this is for multi-threading, try to do some synchronization, okay? So we don't need to worry at this point, okay? Okay, it has some other method. Then over here, what it does, it first create that intercept, and it calls its get method. Okay, the get method is a static method. Within it is create a intersect. Does it create an intersect? Okay, and then it called the storage store. Is it? And create this storage store, that storage method. This is a storage method, it's a store. Is it? It is supposed to, so the parameter type is bank operation. Is it? Is this BOP? This BOP at this point, it's supposed to be null. Is it is supposed to be null? Is it? But this get around with it. Okay, get around with it. Because for the intercept, is it? For the intercept, just call intercept method. Okay, and that's intercept is a subclass of bank operation. And for the bank superclass is constructor, the object not created yet. Is it supposed to be? Okay, but this get around with that issue, it create the intercept object. So that can cause a problem. So the way we should take care of it is for this kind of very critical class, we also need to make it a final class. Don't let it be extendable. Okay, so make it a final class. Okay, so that's one of the approach. And as to the final lies method, that's we haven't learned yet. Okay. And then let's take a look. Number 12 looks like there's nothing we need to worry about. And then what the next one, 13 is, make sure reference to mutable object not exposed. Okay, so over here, anyway, so this is some instance variable, is it? So some class is instance variable, so this is an array, so it's a reference type, but it also make it as a final. So suppose it should be immutable, is it? If you define like this, it's immutable, okay? It's immutable, but you also provide a method called get something, and then you return it. So then you basically kind of exposed it. So what we should avoid with that, because this is immutable. So for immutable, then if you do want to expose its contents, then you can call clone. Okay, because if you do erase clone, it's a deep copy one, not the original one, but you still get to know the value. okay, not the object itself. Okay, then in this case, you avoid expose the reference. Okay, so avoid exposing reference, because here you have a deep copy. Okay, so this is one solution. And the other solution, if you recall, in the collections, that we learned that unmodifiable list method, that so you can also borrow that. Okay, you can then plug in with the array as a list. Okay, then this is immutable, you plug in. Okay, so if it is a collection reference, then we can make use of collections unmodifiable method, the corresponding unmodifiable list or unmodifiable, there is some other data structure you can use. Okay, then in this way, we can also avoid that problem. Okay. Okay, and then let's see the last one. Okay, there is nothing for the last one. So that's regarding rule 5, object orientation. Okay, rules for Java. So make sure next time when you write, when you design a Java class, try to make sure that you follow these rules. And then what next one we are going to go over is about Java methods. Okay, Java method. So the first one, validate method argument. This is pretty straightforward. Is it? We always got to verify methods argument. Is it the argument you need to verify, especially like in this case, it is a reference type. Okay, for the reference type, then here is our mutator. For classes, mutators, is it? You need to make sure whenever you do assignment, it's not a null project. Object. Okay, so that is regarding the first one. The next one is regarding the depreciate obsolete class or method. Yeah, that's, we should try to avoid to use depreciated class or method. That's kind of common sense. What the next one is, so some method in a class that need to do security check, then you must declare it as private or final. Okay, and previously we already saw the discussion in OOP. Is it for the final, because sometimes that we can see some, we call it subclass attack. Make use of subclass, create a malicious subclass, and then start attacking. Is it? But if you make a class method, declare it as private, that's kind of a hide. And if you define it as final, then it cannot be overridden. Because for private, subclass cannot see it, cannot inherit. Is it? And final, it won't allow. Is it? So basically over here, it's just instance variable that or instance method that does security check. We need to either hide it or make it as a final method. So like here, for this method, This is to read a sensitive file method. So it's regarding some security handling, etc. And it declared as a public method. So it does security check, okay? And then in this case, what to recommend you do is you make this method as final method, okay, instead of, so even though you want to make it as public, but then you make it as final. So if it is public, then make it a final, okay? Or we just make it as private so that this can also prevent subclass attacking. Okay, so once again, we see inheritance has some nice thing, is it? Because you don't need to reinvent from the wheel, is it? For a lot of common features shared between superclass and subclass. But on the other hand, we also need to be careful, okay, when we create a superclass. Sometimes some method, critical method, then you need to either hide it or you make it final, okay. So that's regarding this method rule. Then what the next one is, so over here, again, it's regarding superclass, subclass, about inheritance. So when we have subclass create, then sometimes you want to override a method, is it? So here, what the rule says is, do not increase the visibility of overridden method or hidden method. So hidden method, that means a private method in superclass. Okay, then in your subclass, don't provide a public one, the same name one. This means in your superclass, you have a method that non-final method. So it may be protected or public. Is it? Then in this case, when you create a subclass, don't override, don't increase the accessibility, okay? Don't override, okay, sorry. It should be not increase the visibility, okay? So what over here, let's see. This method in superclass is a protected method. Then here is a subclass. For subclass, then you increase from protected to public, etc. So that's not a good design, okay? The good design is then in super, if it's protected, make it as final, okay? So that you won't expose it, okay? So that's regarding this rule. Then next, let's see, rule 5 for method. It's regarding constructor again. So previously we see in constructor, is it? So don't throw exception. And here for constructors, do not call overridable methods, because that can also cause inconsistent state. Okay, so it's going to be an issue. So let's see here. So here we have the superclass, and its constructors, it's called a method. So it's a public method. Because this is a public method, so not a final one, so it can be overridden. Is it? Okay, here's the subclass. The subclass has a method, it's called superclass, it's constructor first, and then initialize the color. Is it? And it also has a do logic. And this method, not an overridden method. And it's public. So both are public. Is it? Okay, then you may see the problem here. Okay, so here, this BC is a superclass. Okay, superclass. And this SC is a subclass. So you call subclasses method constructor. We create a constructor, but we will see it prints the color is going to be null. Okay. Okay, so what over here is it the subclass? It called superclass. Superclass called do logic. But be careful here that do logic, it's not going to call subclass. It's going to call subclasses do logic method. So that's why here to try to access color, but the color not initiated yet. Okay, color not in it because right now it's here. That's it. It's not you put a color here. So that's the issue. Okay, that's the issue here. So be very careful. Okay, that's why when you want to access a color, it's null. Okay, because this is the type of this one is superclass, but the object is subclass. Is it? The object is subclass. So that's why when it called the super, is it the constructor? The constructor call the do logic. The do logic will be this guy's, not that guy's do logic. Okay, so here we needed to be careful. Okay, then how do we solve the problem? Is it so? The problem is how do we solve is, okay, we can make it the final. Okay, so in superclass, you make this method as a final so that subclass cannot override it. Okay, then we can avoid that issue. Okay. So that is regarding this method. And then over here it says, do not invoke overridable method in clone. So previously we said constructor. Is it do not invoke override method. Here, same thing in clone, also do not call override method. That can also cause a problem. Okay, we can take a look here. So here we have an array for instance variable. Okay, then this is a clone method. Okay, clone method. And over here, it's called objects clone. Clone, is it? Then it called the do something. Do something is to set value. Okay, and then it call clones deep copy. So it has a method called deep copy. Okay, so basically deep copy is going to create a new array. Okay, so anyway, so that's regarding this clone method. Okay, and then over here we have this subclass. Extends the superclass. This time it has its own clone method. So override. Is it? In this override, what it called to call the do something. This do something also override superclasses. Is it? What it does is directly access super classes instance variable and do something on superclasses instance variable. Is it the subclass? Okay, then in main. Okay, so anyway, so this is an array. Okay, we create a new array. And this BC is what? Let's see. Clone example is superclass. So this is superclass, but this is a subclass. Is it? So subclass then call subclasses clone method. Okay, so subclasses clone method then what it does, it's called superclasses clone, is it? But then what it does is do something. This do something is going to be subclass. Then it changes the cookies. Is it? It does change. Okay, it's supposed to do it on a copy, not to the original, but over here. So over here, it's on reference itself instead of the deep copy one. Is it the deep copy one? So here is a problem. Here is a problem. Even though the superclasses clone does do the deep copy, is it? But over here it's still on the object itself, so that's a problem. So the best way and the easiest way to handle it is we make the method do something and the deep copy as a final method so that it can prevent overriding of those methods. Okay. Okay, so that's